Everyone, and welcome to another abacus.ai tutorial. Today we will be exploring the AI agents project type. AI agents allows you to build powerful LLM based applications with a custom user interface component. The open source equivalent would be LangChain. When should you use an AI agent? You should use an AI agent when default chat LLM project won't work out of the box because you need to build something very custom, when you need to orchestrate multiple Gen AI steps in a very specific way that you decide, or when you want to combine some traditional software engineering and Gen AI. Let's get started with some examples. The Abacus AI agents allow you to create some user interface like what you see here. Basically, the user inputs some data and chooses the target audience. And this particular agent is a story plan generator. So it's going to go through the data that I send. It's going to generate a plan, and it's going to provide that plan as a downloadable Word document. Here it is. You can even create more complicated user interfaces. For example, this case plan generator, I choose the case type, I click on submit, and based on the results of the large language model from the first step, I'm going to get more options here, like what is the sections, should I add more sections, what do I want to do, click on submit again, and this will actually keep happening. So the model will keep asking me for stuff like the case letter data until it finalizes the process that has been built. Finally, you can also create a conversational agent. So in this case, it has the normal user interface. It doesn't have any type of options. And you can send a message here, and the AI agent under the hood can do whatever it wants with that particular message. Now, let's go back to the story planning agent. I want to show you visually how this story planning agent looks like. If I go to this tab here, you can see the different tasks or steps that the story planning agent does. So I see that it receives some input from the user, it creates two outputs, and you get in parallel a story generator and a boring story generator. And then based on some different checks, we create a story evaluator that gets both the story generator and the boring story generator, and it finds out which one is the best one, basically. This user interface here will be created automatically as you create your agent. And you will be able to create your agent using custom Python code. Now, the next steps are going to become a little bit more advanced, so they are for users who know Python. So if you are happy with just knowing what AI agents can offer you, then you can move and even stop the video now. But if you want to continue, we're going to explore and build an AI agent together. Let's get started. I'm going to go to projects, and I'm going to create a new project, and it's going to be an AI agents project. I'm going to click on continue, test AI agent, and click on finish. Now, the AI agent uses exactly the same format that ChatLLM is using. It has exactly the same components. Deployments work the same way, document retrievers work the same way. There is no difference. The only difference is that you can't just train a model like we are used to. You need to go into agents, create an agent, either manual or AI assisted. I'm going to go with manual now. You provide a name, let's say test agent Theo, and then you choose one of the templates that we have here. So if I choose here, for example, the lowercase agent template, and click on next step, a notebook is going to be created that has the full code that was used to create this agent here. So this is one of the advanced agents, and you will be able to see all of the different steps. So you see it's creating some different functions. Section details is one function, section finalizer is another function, and if you start, if I go to the bottom, I can see how these different functions are actually joined together. So I can see that I have 10 nodes probably, and the case type parser goes into sections finalizer. Then from sections finalizer, we go into section details. And if the execution condition of the case type equals divorce, then the section details go into the divorce letter, or else if it's term insurance claim, it goes here, or else if it's tenancy rental dispute, it goes here. Now, this is a very advanced example, and I think it's going to be very complicated to show this during a demonstration. So what I want us to do is I want us to start with a simpler example, deploy that agent, test it, and I'm pretty sure once you understand the process, you will be able to tackle more advanced use cases. To do this, I pre-created an AI agent, but I want us to go through each line of code together to see how this works. Let's start with what we want to do. I want to create an agent that receives a document from the user, extracts some data from the document, and then creates a Word document report based on the uploaded data. Let's start by importing some libraries, and let me zoom in a little bit here because I don't want you to get lost in the information that exists. I'm importing Abacus AI. I'm establishing a connection to our client so that I have access to our API framework. I'm importing JSON because I will need it later, and I'm also importing a special class called blob input. Let me explain why we need this. When you upload the document into the Abacus platform, for example, if you see here, it asks me to drag and drop a file, so I would actually be able to upload a document here. When you upload a document into the Abacus platform, it automatically gets transformed to a blob input class. And I'm importing it here because I want to import a local file exactly the same way so that I can actually write my code correctly. So if I check my document, it has contents, file name, and it actually has also the size, okay? The contents, it's the most important one, and it's basically the bytes of the particular document. Let's go ahead and extract the document data. I'm going to use a special command through our API called extract document data, which allows you to get all of the text from a particular bytes object, which should be a document. So if I now try extracted doc data dot pages, I'm going to see here that the first 200 characters. Oops, I see the first page doesn't have too much, it seems. Oh, give me just 1 second. Okay, here we are. Sorry about that. I was only printing the 200 character, not the first 200 characters. But now I can see the first page, okay? And I can see the content basically of the first page of the uploaded document. So this is a 10K document from Alphabet. Let me zoom out a little bit again. So I can see here in my code the first page, and then I want to extract two types of metadata, the year and the company name. And this brings us to another important function that you should know. It's the client.evaluate prompt. The client.evaluate prompt calls an LLM, and you provide a prompt. For example, can you tell me hello? A system message, which is basically the global instructions of the model, but it's optional. Talk to me like you are Batman. And you can use explicit name here for what LLM should be used. So if I run this and I print .content, which is actually the response. Oops, sorry, it's not LLM names, it's LLM name. You see here, hello, this is Batman, how can I assist you today? Of course, if I remove this system message and I say, talk to me like you are Aquaman, then the response here will change, even though the prompt is exactly the same. And I can also execute without a prompt. I'm going to use a client.evaluate prompt where I'm going to provide the first page text, and I'm also going to provide the JSON response schema. The JSON response schema forces the LLM to return a dictionary with whatever you ask it to extract. So right now, I'm basically telling it, extract year, which is with a description here, and extract the company name. Here is the description of the company name. And so I'm going to execute this. And if I see the metadata, you see it's a dictionary that has the year and the company name. And that's what I actually used before, using a Python function though, to extract metadata for the chat LLM tutorial. Another thing that you can do through our API is that you can create a vector database on the fly. So get relevant snippets won't call a large language model. It will automatically embed the document, create embeddings from the text of the document, and then it will bring up all of the chunks of the document that are probably related to this particular query, which is risk factors. If I print the combined snippets, you will see this is text from the document coming from that has something to do with this query, the risk factors. I'm sure that you can play around with this more and understand the objects a little bit more. I will leave that to you, but I think you're starting to understand now what process you would need to follow. And finally, what I'm going to do here is I'm going to call client.evaluate prompt again, and I'm going to say, summarize the risk factors from the below text chunks. And I'm going to provide all of the text chunks coming from the vector search. And if I print this, I'm going to get the response of the large language model. Let's put everything we learned together and create an actual AI agent, and let's move step by step through that process. Okay, first of all, and this piece of code here will come out automatically, you don't need to actually worry about this, is some methods, some classes that we require to work with AI agents. I'm going to import that, and then I'm going to create a function called document parser. The document parser takes only one input and it's a document. Before I show you the code, let me just hide it here for a little bit. I want to show you how we actually define the agent. The first thing you need to do is use the workflow graph node to say that this particular function, the doc parser, here it is, should have this name, and the input mappings are workflow no input mapping, it's a document, and it's from a user input, and it's also required. And you can also define an input schema which creates the user interface. So the input schema creates this user interface. I can show you something very cool actually. Let me go back to this notebook, sorry, and let me make sure I don't lose the code here. I'm going to grab this JSON schema as it is. And I'm going to go to the React JSON schema form website, and I'm just gonna copy paste this in the JSON schema. So you see, I can see how my user interface will look like from this website here. As a matter of fact, I could even change this, or better yet, ask some LLM to create the input schema that we need and actually see it here and see if that's what I'm looking for and actually test it. We don't support all of the elements that React JSON schema supports, but we should be supporting like most of them. So I don't think we'll have any problem making something work. If I go back here, we define the input schema and we also define the output schema. The output schema is what is going to be returned by this particular node, and we will have a data URL, and it's going to be a processed document doc. The output mappings are required when you need the output of this node to go to another node. We don't require it right now. Let's recap a little bit because it's very important to understand this whole process. We first created a workflow graph node from a particular function that we defined inside this notebook. If I go back to my to the previous agent, to the law agent template, if I scroll down, you will see that there is multiple nodes here. There is a type parser node, and it has its own input schema, input mappings, output mappings. It has a sections finalizer node, which has its own definitions here. And we continue down with multiple nodes. So if I try to visualize, oops, sorry about this, the agent is not here. Let me just find it a little bit. So if I go to the actual agent here, to the workflow, here it is. Each node that I create is basically one small box here. So each node is a small box. And at the end, you can define how to stitch together these different nodes. In our use case though, we don't require any other node. We can do everything under one node, and that's why I'm doing it this way. Use the templates to see how more complicated nodes get created. Now, I like what I see here. Everything is correct. I have my input mappings, my input schema, my output schema, and my output mappings. And then I'm just going to click on the rest of the code and just register the agent. As the agent is, let's see, undefined variable abacus AI. Okay, so very nice. So it found some lint error in my Python function. It's basically telling me that you are using Abacus AI somewhere. I need to see where exactly I'm using it. Here it is, but you are not importing this anywhere. So I'm going to import Abacus AI explicitly. And this brings me to a very good point. Every library that you need should be inside the function, inside the individual node. I'm going to execute the code again, and I think I don't have any other mistakes. The agent will now register. If I go back to the project, here is the project, Theos agent, and I click on agent, this has started publishing. So this has my code inside. If I try to edit this code, so if I click on edit agent code, a new notebook will be generated that has my function, my node. It has exactly the same setup, and it has new code here so that you can update the agent. Where am I getting at with this? The harder problem is setting up not the function itself, but all of the other elements that have to do, how does Abacus take an updated agent? How does Abacus create an agent? And what are the steps that I need to take? But we pre-populate those. So you don't have to worry too much about those steps. You only need to worry about the contents of your function as well as the input-output schemas. Let me go back to my notebook here, and you see that a new edit agent document was created. This will actually update every time with the newest agent, so you don't need to worry about having a different version in the notebook. Finally, I'm going to deploy this agent. So let's see how long this will take. And while this is running, let's go back to the function so that I can explain the code. Essentially, I took the code from the test code area here. So the code that I showed you before, that I walked through step by step, I used that code and put it in a nice function. So first, we get the metadata from first page using client.evaluatePrompt. Then we get the risk factors using vector search. And then we use some basic Python to create a Word document that has like all of the information in a single point. Finally, we return an agent response, and the agent response is a blob of bytes from the Word document, and here is the MIME type of the document, and also the file name. Let's see if the agent was deployed. I can see the agent was deployed. Let's go back into our project. Let me see the deployment here. I can see there is a dashboard. Let's open it up. Let's see if everything looks fine. It certainly does. Let me grab one of the documents here, upload it, and then I can click on the submit button. Again, the deployment here works exactly the same as ChatLLM. Auto deployment is also on. This means that if I close this notebook now, I go inside the agents and I just edit the agent code. I can run this code. I can make some changes here. For example, let's leave an extra space. I can run this full code and it's going to actually update my agent for me. And the deployed agent will also update. So you see here, this is publishing right now. And I'm also going to see a new version that is pending and it's going to update the existing version. Let's go back to the document parser, deployment here. I see extracting metadata, extracting risk factors, creating Word document output, and here is the result. Let's open it up and see it. Document metadata, fiscal year, company name, and here are the risk factors from within your document. You might ask how we were able to print here the extracting metadata, extracting risk factors, etc. There is another API method that is called client.streamMessage. So this will print stuff on the user interface so that you can actually see them and the user can keep being engaged while he's waiting. So that was all for the AI agents. To recap, use AI agents to create your own custom Gen AI based applications. You can create a custom user interface that can be as custom as you want it to be. All you need to do is change the JSON schema here, which you can also test using React JSON schema form. And if you need some complicated examples, just go into an AI agents project, create a new agent, click here, test, use one of our templates here, and you will be able to see a more complicated process and how we stitch everything together. One final thing, we have the manual create agent phase and we also have the AI assisted agent phase. The AI assisted AI agent will allow you to provide a name, test agent 2, and a prompt to explain what you want the agent to do. Then Abacus will use our APIs to create a template for you with the code that you most likely need. Of course, this is, if you want something very, very complicated, LLM technology is still not yet at a stage where it can provide you something perfect, but it can provide you a very nice skeleton application and you can fill in the blanks and fix as you go. Thank you very much for everything. Have a great day.